time we are adding, subtracting, multiplying, we always had to write it in standard form. What is standard form when you're dealing with complex numbers? A plus bi. Real part plus the imaginary part. So the same is true when we're dividing. We need it to be written a plus bi. So that means we have to get the I off the denominator. Now remember, anytime we get I squared, what does that turn into? -1. So if we can get I squared, that would help us get the I off the denominator. So what would I have to do on A? Okay. We want to take the top and bottom of this fraction times I. It's legal as long as you multiply it by the same thing on numerator and denominator. So the top turns into 3i, the bottom turns into I squared. What is I squared? And 3i divided by -1? So we rewrote this in standard form. We look at B. What would I need to do on this one? Okay. Huh? I was just laughing at them feeding each other, but anyway. So what did you say we should multiply by? Okay, let's see what happens. I heard a 5 minus I heard 5 plus I. Why don't you just watch for a second? And we'll see. So if I multiply by 5 minus I, on the bottom, that would give me a 25 minus 5i minus 5i plus I squared. Does that get rid of all my i's? No. It is going to make these turn into a -10i, but it didn't get rid of my problem. So 5 minus I won't work. What do you think we should do? 5 plus I. Let's try that. So then if we multiply, we get 25 plus 5i minus 5i minus I squared. Will that get rid of the i's? Yes. Okay, so this is the route we need to go. On the top, if we FOIL those, we get 15 plus 3i plus 10i plus 2i squared. So if we combine like terms, 10i and 3i is 13i. 2i squared is on the bottom, positive 5i and negative 5i cancel. So we get 25 minus I squared. So that's minus -1 or plus 1. So combining like terms, we get 13 plus 13i over 26. Right, we need to go ahead and divide. We can divide everything by 13, but that's still not going to be quite the final answer. We need it to be written in A plus bi, so we need to separate the real and the imaginary. So what you can do is put each one over the denominator. That's like 13 over 26 plus 13 over 26i. And then if we reduce, that's 1/2 plus 1/2 I. So because it's an I, it needs to be written A plus bi, we have to separate the two. Any questions there? Why don't you guys try those two? the I off the denominator. So the first one we multiply by I on top and bottom. So that gives us 5I over 9I squared. But 9I squared turns into, or you could write this as negative 5/9I. Technically, I'll take it either way. Alright, B, what do we have to do? Okay, conjugate of the denominator, so 4 minus 3I on top and bottom. So top with FOIL, we get 16 minus 12I minus 12I plus 9I squared. At the bottom, when we get FOIL, we get 16 minus 12I plus 12I minus 9I squared. From here, we are combining like terms. So on top we have a 16, a negative 24I, 9I squared turns into negative 9. On the bottom, the i's cancel, negative 9I squared is positive 9. So we get 7 minus 24I over 25, but can we leave it like that? Okay, so we split it, so it's 7 over 25 minus 24 over 25I. And again, the only reason we have to split it is because standard form for imaginary numbers separates the real and the imaginary parts. Any questions there? Do we need more problems like this? The next thing, in coming sections we'll be solving quadratic equations, and so sometimes we use quadratic formula for that, and we will end up with expressions that look like this. So I wanted to make sure we could simplify something like this. All right. If there is a negative under a square root, what does that mean? Okay, so we can take out an I. But that's not as simplified as we can get. How can I break down the square root of 128? 64. So we have negative 8 plus, the square root of 64 is 8, so 8I radical 2 over 4. But we can't leave our answer like this. So it's negative 8 over 4 plus 8I radical 2 over 4, which reduces to negative 2 plus 2I radical 2. Any questions there? You guys try one. So, the square root of 200, we have to take out an I. We can break it into 102, so that's 10I radical 2. Everything over 5. So we get 2 plus 2I radical 2. Alright, are we good with this type of problem? Okay. Last piece from this section, I want to talk about powers of I. So we have I. If I give you I squared, what does that equal? Okay. What about if I said I to the third? That's the same thing as saying I squared times I. Would you agree with that? What's I squared? Negative 1 times I is negative 1I. What if I said I to the 4th? That's the same thing as I squared times I squared. So negative 1 times negative 1, which is 1. If I said I to the 5th, so we could, that's 2I squared and an I left. Would we agree with that? I squared is negative 1, so it's like negative 1 times negative 1 times I, which is I. And that's where we started, right? So if I did I to the 6th, what do you think I'm going to get out? Negative 1. I to the 7th is going to be negative I. I to the 8th would be 1. So we're getting 4 possible answers, and it just repeats. What it really comes down to is how many I squares can we form. Because every time we get an I squared, we simplify it into a negative 1. So we're going to take some problems with powers of I and see if we can figure out what they would turn into. We know there's only 4 possible answers. Because there's only 4 possible answers, I would expect some work to justify your answer. If you don't show me any work, I'm going to assume you just guessed. So if I said I to the 15th power, what we really have to ask ourselves is how many I squares can we make? If I have 15 I's, how many groups of 2 can you form? 7. 2 times 7 is 14. I need 15 I's, so there is 1 I left. Would you guys agree with that? What is I squared equal to? So we have negative 1 to the 7th power times I. If you have an odd number of negatives, your answer is negative. So this is just negative 1 times I, negative I. Alright, if I said I to the 33rd power, how many groups of 2 can we make? How many left over? Okay, I squared is negative 1 to the 16th. If you have an even number of negatives, what does it become? Positive. So this is 1 times I, which is I. C. If I said I to the 22nd, how many groups of 2 can we form? Are there any left over? I squared is negative 1 to the 11th, an odd number of negatives. I to the 12th. How many groups of 2 can you make? Any leftovers? No. So I squared is negative 1. If you have negative 1 to the 6th power, so an even number of negatives, you get positive. Let's get 1. Alright. Are there questions on this? So here's what I want to do. I'm going to give you guys time to work on your Math Excel. When we have like 10 to 15 minutes left of class, I am going to introduce the next section. I'm not going to give you any homework out of that, but I do want to start it. Because I don't think it's going to take you the whole hour to finish. But, so, work on your Math Excel, and I'll stop you in a little bit for the next
If
one.
I was in one that did that, I would.
Alright, let's get that notes handout that you just put away. So I just want to introduce this for tomorrow. There's a few things we're going to write down. We'll try to get the first part from example 1 done today. We're talking about quadratics, which we have seen a little bit already. How do we know something's a quadratic? What does it have? It has a square. So, quadratic functions, anything of the form f of x equals ax squared plus bx plus c. So that first box, you are just filling in the blank there. And when we graph these, what do they look like? Right. we already looked at the basic, just y equals x squared on the last test. So the graph is a parabola. And when we're looking at our parabolas, we have two options. They're either going to open up or open down, which will determine if it has a maximum or a minimum. So if you think about a parabola that's facing upward, it has a lowest point, so it has a min. A parabola that's facing downward has a highest point, so it has a max. What is the name for that highest or lowest point? Mm-hmm. And do you remember from last year? The vertical line going through the vertex. The graph is the same on both sides, so it's a line of symmetry. We call that vertical line the axis of symmetry. Everybody with me so far? So we're going to start talking about how to graph these things. And our strategy for graphing is really going to depend on how it's written. On the last test, everything we saw was written so that transformations were easy. But that's not the standard form. That was what's called vertex form. So standard form is that definition I already gave you, the ax squared plus bx plus c. Vertex form is when it's written so that we can use our transformation. And all of our transformation rules are the same as we were doing in the last chapter. Nothing has changed there. So what I would like to do is graph the first few of these, and then we'll pick up there for tomorrow with our techniques. If I just give it to you in standard form, the ax squared plus bx plus c, we can't do transformations because we can't look at that and know if we're moving left, right, up, down. So for this case right now, our best bet is plotting points until we have a better option. So we know if we're just going to plot points, we make a t-chart. Give me an x value I can plug in. 1. So if I put in a 1, 1 squared is 1, plus 4 minus 4 gives me 1. So 1, 1 is a point. If I put in 2, 2 squared is 4, plus 8 minus 4 is 8. So 2, 8. Okay, what should I put in next? 3. So 3 squared is 9, plus 12 minus 4.
17.
So 317 went off my graph. So let's try some, maybe 0, -1, -2, see what happens. So if we put in 0, 0 plus 0 minus 4 is -4. Does this look like a parabola yet? Nope, we need more points. If I put in -1, -1 squared is 1, plus -4 minus 4. If I put in negative 2, I get 4 minus 8 minus 4. Negative 8. Do I have enough points yet? Nope, gotta keep going. Now let's try negative 3, negative 4. So if I put in negative 3, negative 3 squared is 9 plus negative 12 minus 4 is negative 7. If I put in negative 4, I get 16 minus 4, which is negative 4. Does this look like a parabola now? Yeah. So the downfall of this is we don't really have just a set number of points that we can plug in. We have to keep plugging in until we find the vertex and get the other half of our parabola. So it's not very efficient. Plus, if my vertex was something like negative 3/4, would we have ever thought to plug in negative 3/4? Probably not. So this is not going to be helpful all the time. What's the domain of this? What is our range? So plotting points works, but it could be time consuming and probably not our best bet. Okay, let's look at one that's written in vertex form. So if it's in vertex form, we can do transformations. If I want you to graph something by transformations, what do I expect you to do first? Yes, I want the parent function. So if you're doing transformations, graph that parent function. So my parent function is the regular x squared. 0 squared is 0. 1 squared is 1. 2 squared is 4. Negative 1, 1. Negative 2, 4. Okay. So what transformations do I have here? What's the negative in front do? Over the x-axis, and the 2, I heard somebody say, stretches. All right, another way to think about it, the negative 2 is in front. Anything on the outside changes y, and it does what it says. So it's like taking my y's times negative 2. So here my y is 0 times negative 2 is still 0. Here my y is 1 times negative 2 is negative 2. Okay, at this point my y is 4 times negative 2 is negative 8. Same thing over here. Y is 1 times negative 2 is negative 2. Y is 4 times negative 2 is negative 8. So we get this skinnier upside down parabola. What's the domain? Infinity to infinity, the range? Okay. What I want you guys to do, graph the last one, parent function and transformation, and we will look at that one first thing tomorrow. So you've got a minute right now. You can sketch this last one, and we will pick up there tomorrow.